Welcome back. It's Joy Benjamin again for this segment of how does linear equations relate to geometry? Well, let's start with a definition of geometry. Geometry is a branch of mathematics which is concerned with the questions of shape, size, relative position of figures, and the properties of space. So if we have a look at a linear equation, let's do a different example from the last one we did. We will take this time the equation y equals negative 2x minus 3. It's just a random equation that I selected here. I took a few minutes to set up both not only the table but also the graph so we can see this graph. Note that the slope in this case is in the negative direction and we have x and y values. Remember that these x and y values keep going, x being the independent variable and y being the dependent variable because y is related to x, and once we set x we are given a y value based on our equation. Well, the other way I can look at this is actually a series of ordered pairs. And if I do that, I get negative 4 and 5, negative 3 and 3, negative 2 and 1, negative 1 and negative 1, etc., etc. So with geometry, we can put these points are in relation to one another and they are in a straight line. Interestingly, when I am dealing with linear equations, I actually only need 2 points. And I could select any 2 points which would define my line. So let's take, for example, we had negative 4 and 5, and we had the point negative 1 and negative 1. Now we know that we've been told it's linear, and so the relationship of these points is linear, and I can take these 2 points and graph exactly the same way as I did before. So negative 4, 1, 2, 3, 4, and 5, 1, 2, 3, 4, 5. We have a point here, and negative 1 and negative 1 is right about here. So I have these 2 points, and because they're linear, they line up with one another, and I can draw my line from these points. I can also figure out what the slope is. So slope, we know, was equal to the rise over run. I'll call it m. We've also defined it as y2 minus y1 over x2 minus x1. And in this case, I take my y2, which is negative 1, and I subtract y1, which is 5, and this is all over negative 1 minus negative 4, which equals, in this case, negative 6 in my numerator, and this is negative 1 is going to be plus 4, which gives me 3, which is equal to negative 2. And I can see that that negative 2 was the same as my slope because I was using y equals negative 2x minus 3, with the slope of y2 minus y1 over x2 minus x1. Well, that's all for this video. Join me for the third segment as we discuss systems of linear equations.